Hello everyone, welcome and thank you for joining us. We're pleased to present this seminar, Optimizing DAS Deployments, a step-by-step approach to DAS deployment testing. The seminar is being sponsored by VIAVI Solutions and will be presented by VIAVI's Director of Solutions Marketing, Kashif Hussain. Kashif's presentation will address today's realities in distributed antenna system deployment. As he will discuss in detail, several aspects of DAS installs are changing, including who funds them, how they can be completed more efficiently, and how they can be tested. The efficiency and testing aspects that I just mentioned will be a particular focus of Kashif's presentation today. You can submit questions using the Q&A window that you see on your interface. Also want to let you know that by attending today's seminar in its entirety, you will be eligible to receive a continuing education credit toward BIXI's professional credentials. In order to receive the CEC, you need to remain on the line with us throughout the entirety of the presentation. When it is completed and we sign off, you will receive a message on your screen letting you know that you've made it all the way through, and that will be followed by an email sent to your account that will contain a link to your attendance certificate. I'll have a little more detail on that as we get toward the end of the seminar, but for now, I'll finish the housekeeping and gives me great pleasure to turn it over to today's speaker, Kashif Hussain. Kashif, whenever you're ready.
Thank you, Patrick. Thank you, everyone, for joining the session. So what I will do is first I will go through the agenda. So what the key things we'll be discussing, right? So where does DAS fit in the overall heterogeneous network? You guys have been hearing a term HetNet a lot, right? And where does it fit in the whole 5G world, right? What role does it play? I mean, part of the small cells, what have you. We'll discuss that. We'll discuss some of the key deployment challenges, right? I mean, especially we'll try to understand the ecosystem, what drives the business case for a DAS. Like, I mean, why would one operator or one set of, I mean, a venue owner, or maybe in some cases neutral host will deploy a DAS. We'll talk about that. Then we'll talk about the different steps from the perspective of when you are thinking about deploying a DAS. So where should I do that and what have you? What steps are needed to basically design a DAS system all the way till the point of optimization when you hand it over, in a sense, a completed DAS project. Different testing requirements. DASs are a little bit more complicated than a typical macro cell or a metro cell, right? So we'll talk about that. I mean, the different phases of DAS, I mean, you have very clear distinctions in this case from an installation and commissioning and optimization perspective. And what tools can we use to improve the deployment efficiency? Also, I will give you a use case of certain small things that sometimes can help tremendously, right? An example of a DAS that was deployed at an airport. So we'll talk about all those details. So let's get into it, right? Okay, so the first thing is HetNets, Heterogeneous Networks. I mean, if you look 10, 15 years ago, most of the network was used to be macro cells, which were conventional macro sites, right? In which you used to have basically coax cables going all the way to the top of the tower, right? And basically the radios and the baseband units and the digital unit, everything was at the base of the tower, and coax cable used to connect to the antenna. There's significant amount of deployments done. There are still some cell sites deployed that way in certain parts. However, with the advancement of radio technology, we now see more remote radios, and we call them as fiber to the antenna, where you have a front haul of comprises of fiber. And there is a trend where we see more and more of that deployment because it offers a lot of benefit, including quality of service, a better signal to noise ratio, what have you. Using the same distributed radio structure, we can build upon DASs as well. So there are two types of DASs. One is the active DAS, and there is a passive DAS. And we will talk about what defines a different type of a cell site in the next slide. So in an active DAS, you will see that there will be basically active components used at the head end, in which you will be down converting, basically taking the RF into and converting into a fiber, basically fiber signal, and the fiber will be transmitting it all around the building. Remember, using fiber, just like in a fiber to the antenna cell site, here it's also, minimizing the effects of PIM, minimizing the effects of basically the losses because of cables and what have you. And of course, there is also a trend of small cells that are getting more and more deployed. Small cells may differ in some cases. For example, you can have a Cat5 type deployment where you will have radio dots or things like that that are getting deployed in buildings. Of course, why would I choose a small cell versus a DAS? That truly depends on the business case for it, the return on investment for a typical service provider, and how it gets deployed. And we will discuss why venue owners are more interested, especially the large ones, are more interested in DASs versus small cells. And in some cases, they go with the small cells when they can offer multiple multiple service providers at the same time. So we'll talk about that in a second. So let's go to the next slide. So this is just a typical snapshot of what kind of different cell sites that are out there that contribute to the overall HetNet portfolio, I would say. So you have Wi-Fi's, which are typically, you will see home, single offices, single office, home office type situation, or medium to large businesses and malls and stuff like that. The power is limited. The coverage is also limited. Although there is a significant number of subscribers that do get support from Wi-Fi. DASs are typically for large venues, as you can see, greater than 10,000 square foot. We are talking about, the power is also quite significant. It's not that low, but it's a little bit different than macrocell. Macrocell has a much larger coverage area, and we'll see at the bottom that macrocell, can provide coverage in miles, right? Then you have femtocells. Again, application is small single office, home office type thing, and so on and so forth. I just wanted to build a picture that why people talk about different type of cell sites. A small cell comprises of a lot of things, right? Anything which is not a macro cell, people call them small cell. The definition changes with the vendor. The definition changes with who you are talking to. Some people call Wi-Fi as a small cell. Some people call even DAS as a small cell. In some cases you would agree with that. Some cases it is very difficult to agree with that situation. So it will be on a case-by-case basis and who you are talking to. Okay, so now let's look at a typical DAS architecture. So like I said, there are two types of DASs. One is an outdoor, first of all, let's separate them, active DAS and a passive DAS. On active DAS, you will see that there is a lot of work going on at the head end where your RF signal that is coming from maybe one service provider or multiple service providers, it is getting down converted, meaning the signal strength is much more significant. You down convert it, bring it to the head end where the signal gets basically converted into the digital domain, and through fiber links you will be sending it to the remote units within the building. And to the remote units, you will still have some coax cables which will be connected to the antenna. So when you see this picture, you can see that there is a lot of stuff going on. You'll have hundreds of fiber cables going around the building, a lot of connectors to be tested, a lot of multiple components there. So you have to optimize how the signal travels through it. Your noise is at a much lower noise floor to ensure that the quality of service is achieved. Right, and of course, all these cables, connectors, antennas, everything needs to be working properly. So we need to do a lot of testing in there. So you will see fiber there, coax there, and depending on, in some cases, we have started to see the twisted pair type DAS situations as well, where radio dot in building environment is used, and people also call them DASs as well. So this is an example of an indoor DAS. We will also see an outdoor DAS, similar type of hub situation. But basically the radio units will be spread out in let's say through canyons or typical roads where you have a coverage problem and what have you. Application differ, and but the objective is the same. Now let's talk about for a second the picture that I have laid out here. There is a rationale for that. And the point I'm trying to explain, why DASs, indoor DASs are so acceptable and people like them in large venues. Typically when you look at let's say take an example of a big casino or an arena, right? The venue owners, they want to ensure that the service is provided for all the different operators that are out there. So typically they try to reach out to these operators, try to work with them, negotiate contracts and what have you. But the key fundamental reason for active DAS in an in-building environment to be successful is because they are technologically agnostic, meaning you can have multiple operators with different technology. I can have a WCDMA technology or LTE technology, or even for that matter, the legacy technologies as well. And all of that signal can be combined. Basically what you do, you have interface trays where you bring the signal strength down, and then you take that signal down to the head end. Remember, all of this needs to be tested at the end of the day. So we'll talk about that in a few minutes. So let's talk a little bit more about how do these typically look like. Some of you may have already seen it in real time, but this is a typical head end, how it looks like. So if you look at that, right, head end is the place where the main hub digitizes the RF signal. So the RF cables that are coming in from the operators, they basically they come into these attenuator trays where the signal gets basically reduced down, and it is fed into the fiber head end in a sense, where it is converted and digitized. From the fiber head end around the building, you will take these fiber cables to the remote units. You can call them RAUs, basically remote access units, and those RAUs will then feed into the antennas. Now it's a little more complicated, and we'll see a couple of pictures. You will see splitters and combiners. Basically one remote radio unit may have multiple antennas connected to it. So so you may have certain splitters going around there as well. So it is a little bit more complicated, but the idea is there. You have a head end on the active DAS where you are converting the RF signal into the digital domain. From there, through the fiber link, you're transmitting it across the venue. You may have hundreds of fiber cables going around, hundreds of radios depending on the size of the venue, and then you will have, similarly, multiple antennas per radio unit potentially. So it's a pretty complicated and I would say, project from that perspective when you look at it. Outdoor DAS, just to give you a quick example, similar to indoor DAS, you can have a hub area where you will have these, basically where you will have converting the RF signal into digital, and then you will be transmitting out where you are trying to provide coverage in certain areas. Now let's talk about the DAS ecosystem for a minute. Like I said, so there are a lot of parties involved in a DAS. So depending on who can be the customers, a service provider can be a customer in this case, a neutral host. So who's a neutral host when we talk about that? So it can be people who are working with, let's say, all the different parties trying to put together, a solution where service providers do not have to make all the investments for the whole DAS project. So multiple service providers can pitch in and provide service within a building. Why is the venue guys interested? Well, nowadays people assume that they will have RF coverage. So venue owners are very much interested to ensure that their buildings are covered. Right? Otherwise, people may even switch hotels if they don't get free Wi-Fi sometimes. I'm just trying to make a point there that there is a lot of interest from building owners in that case. So if you look at it, there are people who are the consulting firms who are doing the design work, who are putting the plans together and all that stuff, right? Then you have the building owners who will be working with the contractors for their building and what have you. Then DAS integration companies who do cable installation, testing, what have you, and then DAS equipment vendors like CommScopes, Comba, Excel, Solid. There are so many of them. Nowadays you will see that. And of course, there are distribution partners like Tesco's and Gray Bars of the world, right? There are so many of them who carry all these different type of cables and tools and solutions that can be that you can acquire from them, right, for providing the testing. And of course, at the top of the food chain, I call them the wireless service providers, which are very much interested in getting their RF signal into those venues and buildings. So if you look at this picture, and you will see working through the person, the contractor who is sitting in the middle, has to ensure that the quality of service is delivered per the requirement of the wireless carrier as well as from a building owner's perspective to ensure that there is a signal the way they want it without impacting, basically the look and feel of the building, meaning they don't want too many antennas in the building, right? Their objective is to minimize the number of antennas and things that can be shown in the building. So with that, the idea of DAS makes a lot more sense, because if every service provider starts putting their antennas, then there will be way too many antennas in the building. So DAS, in that case, I will have one antenna, but I will have multiple service providers basically transmitting in there. So there are certain benefits. However, overall, this is a very complicated picture. And of course, at the end of the day, for every business, there is always the return on investment. So to ensure that the return on investment is there, you need to have multiple parties, meaning multiple service providers providing service, so that the neutral host can make money. So because neutral host, in some cases, they invest a lot of money, they put the DAS, they do the testing and everything. Once they get the certification that, okay, everything checked out, and they integrate the RF signal from the operator, then basically those operators become their tenants. So that's the rationale for doing this. In some cases, building owners want to do it themselves, especially when it depends on hospitals and stuff. Sometimes they get more interested in doing it themselves. Most cases you will see they go a different route. So, it varies from case by case, but overall it is a very complex ecosystem that needs to be understood. Now let's look at some of the key challenges, right? So this was a study done by Infonetics, and what they did, they actually talked to about 20 plus DAS, I would say, operators who are running DAS today. And it can be operators, it can be neutral hosts, what have you. And when the question was asked, what are the key challenges? So the deployment cost is considered to be the significant, key challenge, right? It's quite high for doing a DAS, especially in an in-building environment. Fiber cabling requirements, because now the technician has to be an expert on both fiber, coax, and everything. And the commissioning process for a DAS is also quite engaged. It's not as simple as the fiber to the antenna or a macro cell. PIM is not so much of a problem, I would say, in active DASs. However, still you are using coax cables after the remote point as well as before entering the radio point. So there are some challenges on the PIM, but not that much. And of course, multi-party involvement in some cases is a problem. Operational cost, of course. So this is just a view of it. Now this is from a deployment perspective. If we take another, is from an operational perspective, right? It's a complex ecosystem. So if the performance is not there, who should the venue owner call now? If the venue owner is getting complaints from the customers, or operator is getting complaints from the customers that I'm not getting signal and whatnot. So what do I do? Who should I work with? Should the neutral host be responsible? So those are the key contracts that are signed ahead of time. Who will be managing it? How the performance will be done? How performance measurements will be done? Where the responsibility will lie? Of course, deployment costs, we talked about it. Access to the venue is a big challenge. When I was deploying DASs, what we realized that, for example, if there is a big venue and we have a game going on, so we only are given an 8-hour window. If for any reason, let's say a cable was not correctly done or the antenna was a problem, now the next day I cannot work on it because there was a game that night and probably the whole building was blocked for that night, and so I lost my access for that building. And I may have to wait a few days, so that becomes a cost constraint in some cases, because now you have to fly people out, fly people in, and so that becomes a challenge too. So we need to understand those challenges as well. Service activation time, because operators want to get their service turned up as soon as possible, because there is a coverage issue. That's the reason they are deploying the DAS. And of course, managing, we talked about it too. So now let's look at the deployment steps. First, I will go through the high-level steps, right? And we'll talk a little bit more on each and every one of them from a design perspective, why we do certain things in deploying the DAS, right? So before even the design, there is one thing that is done which is typically considered as part of the design, I would say, right, is usually the benchmarking aspect of it, where you actually take an RF scanner and you do a good baseline to ensure why we are doing what is the intent basically of deploying a DAS at a certain venue. Maybe there is not enough RF coverage. Maybe you're doing a DAS because of actually capacity. For example, at a big arena, you want, when the game is going on, the macro cellular capacity may not be enough. So it may have a different rationale, but it truly depends why the DAS is being built. But doing a good benchmark helps you during the acceptance phase, because then you know what your signal levels were before you deployed the DAS for different carriers. For example, if you have 4 different bands, you may have an AWS, PCS, a 700 LTE, or all those different 4 bands working together. Let's say I'm just giving an example from a North American standard point of view, right? So in that scenario, you will do a good baseline. You want to also see how strong the signal from outside is coming, especially in the cases of when we were talking about a DAS built for capacity. You may have coverage, but you do not want the macro cell to basically be taking over when there is a DAS deployed later on. So then after that, also you do, when you use the data for RF scanning, you can also use that data for the design tool. So there are in-building design tools. For example, you have the RAM plan tool. You have IBWave, sorry. Those 2 tools are there that people can use to do in-building design. And the point of the survey and this CW testing would be to collect the data and basically optimize the models. So when I'm talking about is a propagation model, right? So basically the RF that is being transmitted, you want to see how within this environment, because the thickness of the buildings may be different, you have to account for that. If there are any obstacles in their building where you are going to place the antenna. So the survey is essential. Taking all that information, putting back into the design tool, then you do the first thing, which is the design, right? So now in the design, you will identify how many antennas will be needed, how many radios I will be providing in there, how many, basically from a capacity point of view, how much of a power I need to transmit, and all the number of different fiber cables, whatnot. So you, as part of the design, what you need to build needs to be understood, right? And of course, the design work is very essential in getting eventually the right DAS deployed. Right. Of course, these surveys also help you to ensure code and safety documentation, building environment, places where you can basically access and put, where you will have the roof mounts and all that stuff, right? And analyze the head-end equipment rooms and power and wall space and how the rafters are there where you will be running the cables and whatnot. So that's the whole intent of the first step, which is the benchmarking and survey, and you'll be doing, and then taking that information, you take it to the design tool, you correct the design. Once the design is done, then you basically working with contractors and project managers, you have to do the installation. This is the part where you will spend a lot of time. We'll talk about more in detail with some more pictures and stuff, but at the high level, basically a lot of work needs to be done. A lot of coordination needs to happen because the people who will be installing the DAS at the head end, then there will be a lot of folks working connecting these cables. And of course, when you are connecting these hundreds of fiber cables as well as coax cables, you have to ensure that each and every connector is done right, because otherwise the testing will fail and then you'll have to rework and redo the job. Remember, just having caps on the cable does not mean that the fiber cable is working fine. Still, a micron of dust can impact the integrity of the signal. So you need to ensure that the cables and the connectors are in pristine condition. There are no macro bends or anything like that. And we'll talk about those testing in a second. Right? And once everything is installed, then a significant role is played by the RF engineers. So up to this point, the technicians basically and the people working with cable installation and the construction crew and all that stuff. But now you will bring the RF guys who will start working with the technicians in the commissioning process. And RF spectrum analyzers and CW testers and RF scanners, those will be the tools that will be used, and we'll talk about it in a second, right? And then once Once everything is installed, and now the time comes when you are going to integrate the RF signal coming from the operator's base station into the DAS head end, and basically you will turn it up and optimize to ensure that what the network was designed, basically the DAS network was designed, it's doing as it's supposed to be. And after that, of course, you're in the maintenance and repair, I mean, which is like probably once you've installed it every year or every 3 months or every 6 months. But I mean, there are tools people are working on, I mean, and a lot of vendors are working on, in which they want to ensure that the number of trips to the cell sites, to the DAS locations are reduced by providing much more analytical, I mean, I would say from the core perspective, collecting the data and what have you. So we'll talk about that a little bit too. Now let's go to the next slide. So what do we do basically in a little bit detail? So okay, we'll talk about the test equipment in a second. So next slide. So just to summarize the discussion I had. So what are the deployment steps? What are the resources? And what are the different type of tools you may need? So you may need tools from multiple companies, I mean, and different type of tools. So starting with the deployment step, like I said, you have to do an RF survey. You will do the design. Once design is done, all the design documentation is ready. There are certain documents which are the output of the design which need to be provided. For example, a spreadsheet identified each and every cable, the link budget of every cable, what is the loss that needs to be, I mean, expected from these cables. So all that information has to be provided. And basically, then running the tools that you will have in the field, you will go and validate whether everything is within the link budget, right? So that is very essential. So that will be done in the installation phase. Then comes the commissioning phase, where you will be doing the validation of the DAS completion, the baseline measurements again. You will do the parameter normalization with CW testing. Basically, you will inject a signal at one end. You will take a scanner. You will see how things are looking. You will maximize the sensitivity by, changing the attenuation and things like that, right? So like I said, it's very complicated. Your RF engineers will be engaged at that time. And of course, I did not mention it, but installation is basically your project managers and the construction crew and the technicians, right? The tools will be primarily for the design VIAVI. I talked about the RAM plan. I mean, you will have basically spectrum analyzers at that time. I mean, and scanners, the CW transmitters that you might be needing. Now, from a design, once the design doc is available, that will be an essential document which will be provided to every technician, because as they keep measuring all these losses and readings and taking the measurements, they will have to keep on entering in that spreadsheet. Typically, that's how it is done today, but that can be enhanced, and I will talk about that. And of course, at the end, you will be turning up the backhaul test, and everything will be done from that perspective as well, if you have a different kind of a DAS in that scenario. Of course, all those reports need to be delivered. PIM results need to be provided, right? And once all of the commissioning is done, then the integration, like I said, needs to happen, right? And RF engineers and cell technicians will be working at the site using a walk test or RF optimization tool. They will be basically ensuring that the coverage is done accordingly. And if there is a recommendation for the surrounding site, for example, a macro site may need to be optimized as well, meaning if it is coming in way too strong. So we'll talk about the ingress issues and egress issues and all that stuff, right? Because you do not want now, once the DAS is up and running, the users in the building to be using basically the capacity of the macro cell which is outside. So in those scenarios, you will have to work with the engineers who are responsible for the deployment of the DAS will have to work with the service providers or operators in that case to ensure that everything is done accordingly. Now let's talk about in a second to the key DAS deployment tools. I know there's a lot of information on this chart, and I will go about with some of them, right? So let's just start from the RF end. So you'll have RF cables and fiber cables that you'll be needing, the jumpers for testing and whatnot, different kind of connectors. It's very key that you have the right set of connectors when you go there. So it is my advice to every team that goes out there to work there to have a complete kit built with some redundancies for different connectors and cables, whether they are SMA type or QMA or a DIN or N type cables, have enough jumpers and cables, and ensure before you even go out to the site that they are all tested and they are not bad or broken. One key thing that I've always noticed that even people don't use the right torque wrench. Torque wrenches are extremely important because if you don't provide the proper torque, then you can run into PIM problems. Low torque will allow gaps, and PIM from the center connector is possible. High torque can damage. So just tightening with the hand may not be enough because you can cause PIM, and using some other wrench to really tighten it, you can break the connector. So you really don't want that. So people don't carry torque wrenches, but I think a good torque wrench goes a long way. Then we can talk about the fiber cable test tools, right? So from an inspection microscope, I mean, there are multiple available in the market for OTDR testing, which is very much similar to like the sweep test you do on the coax side. I mean basically identifying the distance to fault kind of a thing. Then you have power meter and visual fault locator, ensuring that all the fiber cables are in pristine condition, ensuring that there are no dirt or anything like that on these cables, right? And of course you need a fiber cable and connector cleaning kit. Power splitters, like I said, it is advisable to carry with you when you are testing it. You will see a lot of power cables in there as well, power splitters as well. Antennas that can be used with the CW testing as well as the scanners, spectrum analyzers. I mean, the spectrum analyzer is one of the fundamental tools for commissioning. Without that, you truly cannot do the testing. Make sure that the sensitivity in a dynamic range is good. A neg 125 dBm or better receive sensitivity is kind of a must-have to ensure that you can measure the noise flow properly. And of course, some spectrum analyzers have the dual functionality. I mean, they can be used for doing like the sweep test as well. So, like for example, distance to fault and VISWA testing and what have you in those scenarios. Then of course you have CW generators. So there are multiple CW generators. I would recommend to carry a CW generator which can support 4 carriers, so that you have to carry less equipment out there, right? I mean, because it significantly reduces your load when you are carrying out to the field, right? Although it is double the cost most of the time. Then you have RF scanners and receivers. We talked about it. You have to capture the signal, and of course then a good lightweight in-building walk test kit for the last phase when you are trying to basically validate the performance of the DAS network. It is essential that you have a lightweight because it takes a long time. People get tired, and of course get too many cables. Try to use a kit which is a tablet-based solution. Otherwise, you'll need more power supply and all that stuff, and the cables going through. So it's recommended to buy solutions which are much more user-friendly. Okay, now we did talk about a little bit, but now let's look at the different things we just discussed, and I will go through them in some detail in a minute, right? So first thing first, fiber test. Like I said, there is a lot of fiber that will be deployed, and every connection, every interface where you are connecting them needs to be tested. So your inspection has to be done, and then you will measure you'll inject. Basically, you will transmit a certain power level, and by using a power check or some solution like that, you can measure the loss, and then you will write it on your spreadsheet that will be provided as part of the design document. Remember, before you start working from the design document, you will have complete specs of how all the radios and everything is laid out in that venue. It will also provide you with a list of each and every radio, each and every cable that is there, so that you can write down what the losses you are measuring. It will give you an idea what the expected loss is, and you have to ensure that everything is within those specs, right? So if it is not in the power is not being met, then you will have to do troubleshooting. Maybe you'll have to run an OTDR test in that scenario. Maybe you have a visual fault locator for any macro band or anything like that, right? So those are the solutions that are needed for fiber. So it's like a typical fiber test solution in that case, right? And of course, for the coax aspect of it, if you're using jumpers and things like that, ensure your jumpers are good quality and everything is done right, and you have basically have the calibration kit and everything, so you can validate that. And then you can run sweep tests on cables, and of course if there are PIM issues, you can validate with using either a PIM tester or basically detecting a PIM using spectrum analyzers. There's some spectrum analyzers that can support that, what have you. Then let's go into the commissioning, where you do the baseline noise measurement, do parameter normalization, meaning you'll be setting the attenuation at different levels, ensuring everything is done right. You will be doing CW testing, basically on the uplink as well. So you will be transmitting and actually measuring at the head end to see what level noise floor and everything you're seeing, and then adjusting for the noise sensitivity. There is a white paper that will be available in which I have published the details of how these testings are done, and actually it does talk about the different spreadsheets and whatnot, like what data needs to be filled out, where the test needs to be done, which points you will be testing these things. So all that information is made available in that. Of course, because of the length of this session, everything cannot be captured, but the idea is that all these things need to be tested. So you can basically review that at your leisure. And of course, once all of that stuff is done, then we can talk about the RF airlink test. So once you integrate the RF cables that are coming from the service provider into this head unit, and then you can do the RF signal and interference analysis. You can do antenna validation report that every antenna is working the way it's supposed to be, and you are on the right antenna. It's like if you are supposed to be on sector 3, radio unit 2, antenna 1, and that's what the signal you are seeing from that radio, right? And of course, validation of the RF throughput and whatnot. So just to give you a quick idea. Next slide, DAS installation. So what do we need to do? Coax cable test, fiber test, PIM test. If there is a twisted pair, then in that case you will have to provide the twisted pair test. What solutions you need? You need a fiber microscope, you need some sort of a cable and antenna analyzer, you need an OTDR test, something which can help you do that, or a solution which can do basically structured cable testing or solution like that. So those are the key solutions. And this is just I would say an example of it, the different active and passive components that you will see, like fibers, you have couplers and splitters and coax, what have you, right? So I'm just trying to give an idea that these are the things that are there that needs to be tested. Of course, you will have to follow the design specs and the design sheet that will be provided by the RF engineer who has designed the DAS, and the project manager will provide the cell site technicians and those guys to go through that, and so that you can provide the reading of each and every one of them. Similarly, I did talk about the commissioning aspect of it. So like the baseline, where I've identified the points where you'll be measuring, for example, the baseline system noise floor. Of course, the details are published in the white paper that you can review the different steps involved in that, downlink functionality testing. So these things have to be done, right, to ensure that the quality of service is delivered by the DAS, and the DAS, the $1 million investment that you're making, right, depending on the size of the DAS, right, you are getting your return on investment, because you need to ensure it is providing the right throughput. It is providing the right capacity. For that, all these interfaces need to be working properly. Antennas are connected in the right place. You are not transmitting, they are not switched or anything to that effect. And of course, post-built CW testing I talked about, uplink functionality testing, maximize sensitivity, and after that you will do RAN integration. And I've identified some of the tools that I've seen people use in the industry. There are solutions out there which can help you for RAN integration and optimization, like that once you have done, take a walk test kit, the solution that can help you identify antenna fault, macro to ingress handoff, or zone overshooting. So if in some cases maybe there may be some problems because of which you may be seeing certain zones which may be transmitting in areas where they shouldn't be. So you may have to do some optimization there. Of course, the RF data fill and KPI analysis has to be done as well as part of one of the deliverables before a service provider accepts a DAS. And of course, with everything you have to take pictures, ensure that everything was done right. Like for example, when you will run your spectrum analysis, the noise flow test and all that stuff, you'll have to provide all those pictures as part of the acceptance package when you are providing this testing. So let's go through a typical use case for improving the commissioning aspect of it. So there are multiple tools that are out there in the industry. And today, let's follow the process of DAS installation. So like I said, from a design tool, what happens that an engineer, design engineer, takes that information, generates this Excel spreadsheet, takes that information, sends it to the contractor who actually reviews it, works with the venue people, works with the cell site technician, the technician at the site, the construction crew, and basically that document and the spreadsheet is used to validate each and every cable based on the design and specification. Once all that work is done, then tools, don't worry about the tools that you see there, because the tools can be different. You need a cable and antenna analyzer, you need an OTDR tester, you need we already talked about that, the optical microscope and all those things, right? It will be needed there. So once all of those tests are done, the technician will fill out these spreadsheets, provide it back to the project manager, who will send it up the chain. As you can see, there are too many handoff points, too much manual stuff going on. So the probability of error is very significant. And the engineer, the design engineer, does not have visibility till he gets back all the reports and everything. So and sometimes people miss reporting which link they were testing and whatnot. So it is a very complicated process, and sometimes it can cause delays, and because different companies and different parties are involved in the testing and overall optimization, because some things get subcontracted, as you always know, in this business, right? So to improve that, I have seen multiple companies using cloud-based solutions in which will take an input from the design tool directly, and it will create kind of a job task type thing. Even if it does not take the cloud input, you can take these spreadsheets and directly input into the cloud-based solution, which will connect directly to the instruments. So when these instruments will now have identified each and every link. So now no manual work required there, and the accessibility is to everybody at the same time, meaning the carrier, meaning the service provider, the contractors, and the technicians, and they can also see that how many links they need to test. And these tools are connected, so as soon as you connect the tool, they know which link it is based on the input that was originally provided at the start into this cloud-based solution. So this significantly reduces the time, first of all, the back and forth time. Second, the visibility is there. Third, the error goes away, because now you know which link was tested and what time and what was the expectation. For example, if I was supposed to measure a loss of X dB and now it's a Y dB, which is beyond, let's say, 2-3 dB range that was provided relative, then it can be quickly identified as a problem. So it reduces the risk of repeat visits and whatnot. So there are solutions out there, and I personally believe that those solutions should be considered that can significantly reduce the overall, I would say, the installation time. In fact, commissioning results can also be directly integrated into that. Basically the results can be easily, right? So everybody has the visibility at the same time. Now, let me talk about a use case. So this is an airport in-building DAS that was being installed. So single mode fiber that was going to the remote units. Remote units were located in a remote electrical closet quite far, about 2 to 9 kilometer links were there. APC type connections were there on the fiber, and there were 4 different parties involved. So I just wanted to give you the scale. And what happened that when they brought it up, so there were 50 to 60 60 radio units at there, and there was a 20% failure, because people assume, I see the green light and I have a cap on the fiber, everything will be fine. I just hook it up, powered it up. As soon as they powered it up, there was a 20% failure. And because of different parties working and the time frame, accessibility, whatnot, months were wasted in the whole process. Then at some point, we were asked to come out and look at it. So we brought our OTDR test, basically insertion loss qualification and fiber certification tools. And the first thing when we looked at it, we audited the fibers, and we found that there were dirty and damaged fibers, as well as that there were some card issues too. So we turned up 3 RUs, radio units, out of the 20% failed. As you can see, there was about 10 or so, like within the first hour or so, which was not being done. So having the right set of tools, performing the right test can significantly truly reduce the time. And if you want to basically, if you follow the right steps and get the right set of training, then in that case you can significantly reduce how quickly you can install, commission, and launch a DAS. Again, we have to remember, time is very limited, especially in venues. Sometimes we don't get even access to venues for days. So you don't want to be the guy who's like, okay, I did part of the work, now that DAS failed, I have to fly back again. So that was my point. But anyway, so that's pretty much what I had. I will open it up for question and answers. So,
Kashif, thank you very much. Thanks for all that. I will let Kashif take a breath after that presentation. Thanks very much. I'm also going to put a slide in front of the audience right now. A little bit of housekeeping for you before we get back to Kashif with questions. To those of you who can use your attendance today to obtain 1 continuing education credit toward BICSI professional credentials, please stick with us through the entirety of the presentation. When it ends and when we sign off, you will see a congratulations screen. What's going to happen then, that's a visual indicator to you that you've made it all the way through. You're done and you have earned your certificate. That will also prompt an email to you when you registered for this seminar today. You provided us with your email address. An email will be sent to that address, and the email will contain a link to your attendance certificate. Caveat there, please give us about an hour or so for that email to arrive. Because it is an automated process, it does these emails kind of one by one. So with the number of attendees that we have on today, it's possible that it may be up to an hour or so by the time you receive an email from us with a link to your attendance certificate. Now, if you have patiently waited an hour or so, or even more, and you have not received such an email, possible that it's in your junk folder or spam filter or something like that. But if it's simply nowhere to be found, the email address that's on your screen right now is where you can contact us. Webcastmaterial@penwell.com is where we can be reached. And if you stuck in there with us, hung in there with us, and got your congratulations screen but did not receive an email with a link to your attendance certificate, that's where you can reach us. We'll verify that you attended and we'll get that certificate for you. A little bit more from me before we get back to Kashif. When that congratulations screen appears to you, you'll have the option. There'll be a button there that says continue. If you press that continue button, it will take you directly to the white paper that Kashif mentioned while he was presenting. White paper has been authored. VIAVI Solutions has authored a white paper that's a very good companion document to today's seminar. So if that's something that you would like to have and keep, please do hit continue when you see that congratulations screen. And again, you will be taken directly to that white paper. So that is about it for the housekeeping from me. And we are about to scroll through some questions and see if we can send any Kashif's way. So thanks, of course, everybody for joining us, and please sit tight for just a moment while we sort through some questions and get to Q&A. So just one more moment, please. thanks everybody for hanging in there with us, and thanks for filling up the question queue. Cash, if you've had a chance to take a breath and get a drink of water, I have some questions all queued up for you.
Okay.
Thank you. One asks, what is the cost of installing a DAS system in a typical construction project? And I'm gonna editorialize on this a little bit. I bet it's difficult to pinpoint, right? There might not be take square footage times this times that, and you've got your number. But I don't want to assume the answer. I'll let you give it. But the question was simple. I suspect the answer may not be. Cost of installing a DAS in a typical project, as if there is one.
I cannot provide you a number. The reason is because every project is different from, one project is different from the another one, right? And it all depends the square footage of the location. There are some studies done. I don't have a number in front of me, but for example, there are competing vendors, right? For example, people who are looking for Wi-Fi type solutions versus DAS type solutions. So I'm sure that I've seen some numbers that Wi-Fi type companies have done for active DAS type solutions and try to share those numbers, right? And it truly varies how big the venue is, how complicated the job will be at those venues. How much of cabling work that needs to be done on those venues. For example, if it's a new building, your cabling cost can be significantly lower, right? But if it's an older building, and if you have to find a closet for basically installing your head end and whatnot, your cost can be quite different. So it is not that easy, but if you, and I don't want to quote the numbers because I don't trust these numbers that I've seen out there because it varies per square footage. There are companies who have done some analysis and they have identified for an active DAS, some XYZ number per square foot, and you will see that. And that can take the installation cost in few millions of dollars depending on the square footage of the building. So to quote a single number is almost impossible. It will truly vary whether you are doing a stadium, what size of a stadium versus a hospital, and what size of a hospital. So it really varies. It's not a simple question. I apologize, I cannot give a simple answer to that one. Just like Patrick said so.
Thanks, Kashif. Another one, maybe this one will be a bit simpler. In your presentation, a few times you used the acronym WSP. One attendee asked, could you remind us again what that stands for? WSP used as an acronym in this discussion. Wireless service provider. Thank you. Provider.
Basically, service providers. We call them operators, service providers, carriers, multiple things, right? So.
Right, and sometimes the names are used interchangeably, right?
Exactly.
Another question. Evidently, somebody's been in situations and environments in environments where I'm inside a building or I'm somewhere and I've got a pretty good cell signal right there. If I'm standing on the third floor of an office building or whatever it is, and I've got I take my phone out and I've got a good signal. Does that mean that a DAS is not in my future? Or is there a way to know, beyond taking your phone out and looking for a signal, if an environment is a prospect for an indoor DAS?
Right. So let's take a typical example of a stadium, and that's where the problem with the business cases. If you go and talk to a wireless service provider and tell them that in this stadium I have like 5 games in, let's say, in a week, right? Versus a stadium where there are only a couple of days you use that network for 6 hours. So then it becomes a return on investment problem. Because now, what kind of a stadium is that? Is it a place where you will be playing, let's say, a Super Bowl, or is it just a small stadium somewhere else? So it truly depends. What I'm trying to say, it truly depends on the business case of it. Because in stadiums and a lot of stuff, you will see there is a lot of data on the uplink being used as well. So I truly, if you look at it, yes, I have coverage in that stadium, and I have enough capacity during normal business hours from, let's say, 9 to 5. But when the game starts, guess what? That coverage that capacity went away because people are now uploading pictures and uploading videos and all that stuff. So that's where the service providers will have to make a decision. Is it worth it for them to provide service. That's provide a service there. And especially you don't want to be the guy. You will see a lot of DAS deployments are done for all the key venues, places where you have Super Bowls and whatnot. And you will see there are service providers who have actually advertised that they have invested significantly in those arenas or whatnot. The reason is because they want to provide the excellent quality of service in those specific venues. Now, to answer your question, why would I do it? The answer is very simple. If I guarantee a certain quality of service, do I guarantee only for certain hours of the day, or do I offer it 24/7? If I'm one of those operators who offer 24/7, then I would be very much interested in increasing the capacity in those venues where, during busy hours, the macro cellular network will not be able to handle. Those are the key things that they need to look at in places where you have macro coverage, but my macro coverage may not be able to handle a certain influx of 100,000 users which are coming into the network.
Thanks very much, Kash. If I'm looking at the clock, I think we may have time for one more question and answer before we hit the top of the hour and let the audience go. So I'll send this one your way. Asking about a neutral host or an enterprise-funded DAS deployment. So in that scenario, the question concerns RF engineering expertise. Specifically, who provides the RF engineering expertise in a neutral host or enterprise-funded DAS deployment? And the question further asks, how interested is the mobile operator going to be in collaborating with these types of deployments that can, assist their competitors as well? So I guess if I'm putting all the pieces together correctly, in a neutral host or enterprise-funded DAS deployment, should one realistically expect RF engineering expertise from a mobile operator, knowing that other operators are likely to be, to be supported in that space?
That's a great question, and I'll tell you my personal experience with one of the neutral hosts that I have worked with, and the learning that I got that neutral hosts typically are very much interested. So consider them like I would call them, in a sense, a landlord, right? And here the landlord is not selling the space; they're actually selling the power, the coverage, the capacity, and the throughput, right? So they work with these service providers and have an agreement on the level of service that they will be offering in these buildings. So typically what I have noticed with neutral hosts, that what they do, that they have their own RF services. Of course, in most cases they can be contracted out as well as have some of their own resources as well, because they augment the resources as needed. Since neutral hosts can be in multiple locations, meaning I'm doing one DAS in Michigan, I'm doing another DAS in Texas, I'm doing another one in California or New York, right? So I cannot have full-time people all over the place. So what will happen that they will be subcontracting the resources from different companies for RF engineers as well as technicians and what have you. Just a typical deployment scenario, right? And so now the responsibility for the design may lie with the neutral host themselves, right? And then after it is deployed, then in that case they will be hiring other resources for optimizing and whatnot. Now let's go back to the question of the service provider. From a service provider's perspective, their objective is to ensure the contract that they sign with the neutral host for providing the certain quality of service. For example, I'm designing a DAS where I'm going to do a 1 megabit per second throughput across this building. I want to see that my coverage for my phone. So when the engineer is walking the site, they will be downloading and uploading data for all service providers, and they will be providing the results to each and every service provider. For example, take operator A. So our service provider A needs to make sure that they are getting the results. So the key role is played by the neutral host in this case, as long as the service provider contract is being met by the neutral. So that's my experience has been. There may be different models. Enterprises may be a little bit different how they want to do it. They may completely outsource the work because they are not going to have an RF engineer on their staff. So the whole thing can be completely sourced out to some other entity, right, which can be integrating the whole solution for them. So it will vary, right? They may still have a say of how they want to see the DAS, what they want to see it, but they may not have a complete authority or control in how everything comes together. I hope that answers the question.
Kashif, thank you very much for those answers and for today's full presentation. A couple of things, a couple of notes to members of our audience. Thank you everybody who submitted questions. I know that we got a bit of a flood of questions once our Q&A began. So please know that although we're about to sign off, your questions do not necessarily disappear forever. And I'm going to fall short of telling you that we promise to get back to you, but please know that your questions are captured and available to us. So it is possible that some of you who submitted questions that did not get answered here today by Kashif may be hearing individually sometime in the future. So thank you again for your attendance. Of course, thanks go to VIAVI Solutions and Kashif for today's presentation. Now, as we sign off, please remember a couple of things. You will see a congratulations screen. That means that an email is on its way to you with a link to your continuing education credit. Also on that congratulations screen, if you press continue, you will be taken directly to the white paper that is a very nice companion document to today's seminar. So thank you everybody for joining us. Thanks to VIAVI Solutions and Kashif for today's presentation. And we look forward to meeting some of your information needs in future seminars as well. Thank you all again. Have a good day.
Thank you all. Bye.